Start recording. Okay, so that brings me on to a good point. So there's a lot of discussion about what's happening with schools, a lot of discussion about what's happening with prelims. Okay, the window for the prelims is mid-February to sort of early March. All right, so we're probably targeting closer to March just because the way things are going and the progress of that. So I'll give you a full breakdown of what's going to be in that prelim. Obviously, everything we've covered in Unit 1 is going to be in, okay, but we'll give a full breakdown of that with a good few weeks to spare. Okay, so I'll try and, in fact, I'll have that for you next week, give you that breakdown. We'll look at it. Probably won't have the full date next week. That will still be up for debate. We are in discussion with SQA about what happens if someone doesn't want to go in the building, or if we can't get in the building, if the government says we can't get in. I don't think the government will shut the school. Okay, that sort of dictates what we'll do exam-wise. Okay, because if the schools don't do the prelims in the building, then that will spin off from that. Okay, as we stand right now, we are still doing some physical classes in the college, even now, even this week. Okay, so if it's practical classes and they can't get in, or if we're doing assessments, they can come in. Okay, it's still allowed. So the rules, even though they've been tightened up a lot, still looks like, touch wood, we can get in the building and the prelim will be held in person. But let's see how it goes. All right. No socialising over Christmas. I think that's a message. I'm not sure. All right, but hopefully we'll do that. So yeah, prelim will be sort of mid-February to early March. Specific date will looks like more likely to be early March. All right, but we'll have that in plenty of time, and we'll have the full breakdown of what's going to be in that. As we speak, the prelim will be the evidence that we use. Okay, if we need evidence in regards to appeals at the end of the year, or if we need to suggest any sort of marking at the end of the year. Okay, hopefully it doesn't come to that again. Okay, because last year was a bit of a shambles. But who knows? Who knows? I'm giving up. Okay, so the prelim is probably the biggest bit of evidence, or will be the biggest bit of evidence. Again, we're in discussion about how we can sort of prop that up. Yeah, we'll get there eventually. Who knows? Who knows? Okay, so perfect. We've got a wee question for after break. I'll go through that. Anyone else has a question, give me a shout or drop me something on the chat, and we can go through that as a group. Okay. If you're sitting on a question, I bet you someone else is. Okay, it's almost a guarantee. If we were in the classroom and we were together, we'd be chatting. Okay, some of these things would come out naturally. It's quite inorganic, I suppose, this sort of setup. But if you need something, just put your hand up, put a message out, something. Okay, don't sit on a question. Other thing I wanted to discuss, someone was having issues with YouTube streaming the videos. So the links I'm sending, I'm saying it has to be downloaded. Is that common across the board? Is anyone having issues with that, or is it streaming okay when they're going on YouTube? Okay. I don't know what the solution would that be. I don't know why it's asking to download. It might just be the device you're on. I don't know. But if it is and it's causing bother, then we can get IT or someone involved. It should just stream like a normal YouTube video. I've not set it up. I don't think I've set it up with any other permissions. Okay. It should allow you access to, I think there's 12 videos now. Okay. Those links should give you access to all 12 videos. Okay, it might be in playlists, so I think there might be different options up the top. Okay, for the channel. Okay, so if you go into videos, it might not show anything, but if you go into playlists, it will give all 12. Okay, so everything should be there. Okay, so I had a wee double check of that, and it seems all to be working and live. So I don't know, it might be a device or yeah. But if there is issues, we can get IT involved and we can sort that. Okay. Also, something came up in discussion. So someone in the class has said they found a resource that was quite good. So I've had a very, very quick look at it. I've not been able to mess about with it much. Let's have a wee look. Share. Not that. Oh. All right, and it's free National 5 Maths whole course, and it seems to be pretty up to date. And I say that because it's got all the 2022 exam dates, course changes, okay, and it's got a bunch of stuff in there. Now, I've not been through this. Someone's just told me about it there. On the face of it, it looks pretty good. It's given a bunch of practice stuff. It gives exam dates and details. And I think somewhere there's past paper questions, but it breaks it down as well. All right, breaks it down into different worksheets for different parts, and it gives you the answers. All right, so on the face of it, it looks all to be free. It all looks reasonable. Okay, certainly for Nat 5, certainly everything we do. Okay, so it might be something to look at. So I'll put that in the chat. As I say, I've not gone through it all, but it's another resource. Okay, it looks quite good for practice questions and answers and marking schemes. So if that's like proper marking scheme breakdown, that'd be pretty decent as well. Okay. If anyone finds anything they want to share in here and it looks good, again, give me a wee shout and we can look at it together. All right, but on the face of it, there's a lot of good stuff in that. All right. Super. Okay, so I've put that in the chat. I think that's what I was wanting to discuss. Okay, that's what we're looking at today. No cheating. Okay. Superb. All right. I think that's everything I needed to cover. Yeah, we'll go with it. We'll go with it. Okay, so today we are building up our understanding of what a formula is, what an equation is. Okay, and we're going to start looking at straight lines. Okay, now that sounds odd. Oops. Sorry, just clicking buttons here. Keep that over there so I know people are there. Okay, that might sound odd, okay, but we'll start looking at the equations, the algebraic equations, and start looking at what they mean, okay, because what we've been doing until now is sort of building that sort of understanding about how we can manipulate it, how we can swap them around. But these actually mean something, okay, the x's mean something, okay, the numbers mean something, okay, so we'll start building up an equation for a straight line. Okay, and that sounds pretty odd, but do a straight line, and then we'll build into sort of curved lines when we look at graphs. Okay, and then we'll build a few more expressions onto the back of that as well. Okay, so the first thing that we want to look at is something called gradient. Okay. So the first thing we want to look at is something called gradient. Gradient, you've heard the word. Okay, you've heard the word that it's quite a common word, gradient of a hill. Okay, that's exactly what it is. It's how steep that line is. Okay, so if we've got straight lines like that, we're going like that. Okay, how steep, how quickly they go up is going to be the gradient. Okay, so it's just the steepness we're going to look at. Okay, and that's important when we start building up equations of straight lines. Okay, so we're just started building the building blocks. We're starting to put things into sort of context here. Okay, and then we'll build on it and build on it. Okay, so the steepness of the flat line, and it's just the relationship. Okay, between the change in vertical distance and the change in horizontal. Okay. Does that make sense? Because if you're going up a hill, you're going horizontally forward, you're also going up. Okay, if you're going down a hill, you're going down vertically, but you're also going along. Okay, so it's a relationship between the change in vertical distance, how quickly we're going up, and the change in horizontal, how quickly we're going along. Okay. The letter that we use in math to represent gradient is just the letter M. Okay. The reason we use M, don't know, no idea. Okay. I think it's just an arbitrary letter that someone's picked when they started looking at it many years ago. Okay, so there's lots of letters like that. Okay, like C is the speed of light. Okay, and can't think any other ones, but there's lots of letters like that in maths. Okay, so M is just the gradient. So when we do the equation, we're going to write gradient as M. Okay, that will make more sense when we start building the equation around it. Okay. Couple of things to look out for. Okay, the gradient is going in an upwards direction. We're going to say that it's positive. Okay, so gradient would be a positive number, positive integer. Okay, gradient would be 5, gradient would be 10. Okay, that's going to dictate it. Okay, if it's going the other way, okay, it's going down like that. Okay, that's a negative gradient. What this is good for is when you are double checking your answer. Okay, so if you get given an image in the exam paper, or you get given an image in the assessment, and the line's going a certain way, you should be able to immediately recognize it. That's going to give me a negative answer, or that's going to give me a positive answer. Okay, in regards to the gradient. Spell negative, right? Okay, so that's just something that we want to look out for. There's two more things that shouldn't happen in that 5, and that's when we get a 0 gradient, which just be a horizontal line. All right. Okay. You shouldn't see that. Okay, so if you're getting a gradient and it's coming out as 0, ask questions. Okay, and also we shouldn't get a gradient that gives a vertical line. Okay, a pure vertical line. We actually call that undefined in maths. Okay, it's not possible to get a gradient of that. Okay, because it's not going to along horizontally at all. Okay, so you shouldn't see them. If you're getting a gradient that equals 0, or you're getting a vertical line, you know something's going to be a bit awry. Okay, so those are the sort of 4 directions of lines that you're looking for. All right, and as we go through examples, that will become more apparent. Okay, we should not see these. Okay. You'd hope. Nah, you won't. Okay, so as I said, gradient. Wow. Equals change in vertical over the change in horizontal. Okay, say that was a change in height, change in length. Okay, but essentially that's the equation we're looking for. Okay, so we're looking for a fraction. So we've been looking at fractions for quite a bit. So being able to simplify fractions again becomes important. All right, so being able to simplify, I've never seen something outrageously complex in gradient. Okay, they usually do look for quite a nice answer. So just being able to simplify normal numbers is important. You know, so that will be a skill that you pick up through practice. All right. So if, just put a wee note beside that, if it is a fraction, okay. And often they are, okay, you must simplify that down. Okay. That's something we stick to in general. Okay, so if it's a fraction, if it's an algebraic expression, we always look to, can we simplify that? Always look for that one next step. All right, does it filter down any further? Okay, so best way to do this for the first wee bit is using square paper. Now, I don't have that on the iPad, so I'm just going to show you some examples in your workbook. Okay, so this in your workbook is sort of how they show it. Okay, so this is page 36. Okay. This is sort of how they introduce it. Now, it's quite valuable to do in regards to understanding it. Okay, so instead of trying to draw it out and try and make squares on my iPad, let's just talk through a couple of these. Okay, so calculate the gradient in each line in the diagram opposite. Okay, so what are we talking about with the gradient? We're talking about the change in height. Okay, so how does it go up? Okay, divided by the change in length. Okay, using just these boxes, so we use these boxes as units. Okay, for I, okay, it's going vertically up 4 and horizontally 2. Okay, so the change in vertical height is going to be 4, horizontal change is going to be 2. All right, nothing more complex than that. So let's just have a wee look at the iPad. Okay. Spelling gradient different every time. Okay, I'll use M. M equals change in what? Change in vertical or change in horizontal. Okay, so change in vertical, that question was 4. Change in horizontal was 2. Okay, so it went up 4 boxes. It went across 2. Okay, so the gradient for that line is 2. Okay, so the gradient of that line is simply 2. Okay. So when we look at the next one, looking at the direction of that line, okay, what we're going to pull out from it first off, we just need to be able to recognize that's going to be a negative. Okay, it's going down, you're going downhill. So if you stood at the top of that and you took a step, you would start going downhill. Okay, so it's going in a negative vertically, that it's going negative vertically. Okay, it's going down. Okay, so how do we write that out? 1, 2, it's going down 2, and it's going horizontally 4. Okay. Changing vertical, -2, horizontally it's going 4. Okay, that would need to be simplified down, simplifies to -1/2. Okay, that negative sign shows the direction that that line's going. Okay, so just a wee quick note, if either the top or the bottom's negative, then the whole equation is going to be negative. Okay, if the top and the bottom are both negative, then the equation becomes positive. Okay, that's just a standard rule. Okay, we'll see that coming through. Okay, right, have a wee go at 3, 4, and 5. It should be nice and easy. Okay, in fact, what's the difference in that question and that question? No issue. Okay, so just have a wee go at 3, 4, and 5. Just find the gradients for me. Okay, just take 2 minutes doing that. Okay, so 3, 4, and 5. Just find the gradients. Take till 35 past. Then we'll come back in. Recording. That's still sharing. Okay, so 3. In fact, I'll just show you. For 3, I got 4/3. Okay, in a fraction, we can't simplify that down any further. Okay, changing vertical, changing. Most important thing there is positive. Okay, 4 negative. Okay, it's going down 1 and it's going along 6. And then 5, it's going along 3 and up 3. So I got a gradient of 1. Okay. Happy. Okay, so gradients not too bad. So just about how steep that line is. Okay. What question 3 is asking, I won't ponder too much on it. Okay, what it's looking at is a concept that a straight line, the gradient doesn't change. So no matter how many points that you want to take, the gradient is going to stay the same. Okay, so I think that's what that's trying to look at there. So it goes along 2, 1, 2, 3, 4. Yeah. Okay. So if you go out 2 boxes and up 4, okay, you could do that at any point there and get the same gradient. Okay, so if you go out 1 box, it goes up 2. Okay, so you're going to get the same gradient no matter what you do. Okay, and what point you take it at, if that makes sense. So as long as you go at least out 1 box, you'll get the same gradient all the way up that line. Okay, so that's just, so it's the same as question 1, but they're just taking a wee snippet of it. Okay, so don't worry too much about that one. Okay, so where do we use gradient? Okay, we use gradient when it comes to straight lines, when we see them in graphs. Okay, So let's think about graphs and look at the basics of it. Okay, so what am I talking about when we talk about a graph? Talking y-axis. We're talking an x-axis. Okay, y is going to be your vertical axis, x is going to be your horizontal axis. Okay, graphs are pretty damn useful things. Okay. It helps us look at relationships. Okay, so relationships between two variables. Okay, y being one variable, x being the other. Okay, but you can look at loads of different things. So y could be like distance you travel over a certain amount of time. Okay, y could be how hot something can get over a certain amount of time. Okay, there's lots of different ways you could put variables into that to track them. Okay, so we're going to use the coordinate system. Okay, where we do x, y coordinates. Okay, and we're going to use that to look at shapes of graphs. Okay, starting with that straight line. Okay. So our x and y coordinate, let's put that a wee bit better. Okay. We write a coordinate, we're going to have an x, we're going to have a y. Okay, that's going to be the number on the horizontal, that's going to be the number on the vertical. Okay, when you see coordinates, that doesn't change. Okay, it will never be y first. Okay, it's always x, y. Okay, it's always a horizontal number first, and then the vertical number next. Okay, there's always going to be a scale in these graphs, so it's always going to go up. Okay, so if we look where I've got x and y crossing there, okay, that's going to be coordinate 0. Okay, 0, 0. Okay, that means the x is 0 and the y is 0. Okay, if we put a scale on this, vertical as well. Okay, we can start thinking of other coordinates here. So we had a point here, that coordinate would be 1, 1. Okay, you've come along horizontally by 1, and you've gone up vertically by 1. Okay, we had a point here. Oops. Okay. Okay, you've gone along horizontally by 4, and you've gone up vertically by 3. So your coordinates 4, 3. Okay. Now we can also do negatives on graphs. Okay, so you can also have negatives in the same way. Okay, on both the horizontal and the vertical. Okay, so if we had a mark here, okay, you've gone horizontally -2, you've gone vertically 1. Okay, so you have -2, 1. Okay. One up here. Horizontally -4. Okay, so and then the final all right. You can start to see we can plot things on graphs. Okay, so there's two axes, the horizontal axis, which is going to be commonly known as the x-axis, and we've got the vertical, which is commonly known as the y-axis. Okay, and then we've got our coordinate system. It's always the x number first, and then the y number second. Okay, and they're going to be separated by a comma. Okay, so it's that coordinate system that we're going to use, and then we're going to combine that with what we're thinking about graphs. Thinking about straight lines. Okay, so we're going to use that coordinate system to think about how we can work out. Okay. Consistent. Okay, so straight lines. We've got a line in that graph, like such. Okay, it's straight. Okay, we can pick 2 points on that line, or we can be given 2 points in that line, and we can use those points to work out the gradient. Okay, so if we get given a line like that, we could get given 2 coordinates. Okay, so you remember what gradient is? It's just the change in vertical distance over change in horizontal. Okay, so if we get given 2 points in that line, okay, say point 1, we call it point A, okay, we get an XY coordinate for that. Okay, point B, we get an XY coordinate for that. Okay, we can call that X1, that Y1, call that X2, call that Y2. Okay, that will allow us to come up with the expression that M equals Y2 minus Y1, okay, which is the change in vertical distance. Okay, so your second point minus your first point. Okay, so your second point is your Y coordinate for B minus your first coordinate for A. Okay, divided by x2 minus x1. Okay, change in vertical. Change in horizontal, or x. Oh. Let's go back to this and then put 2 coordinates on that. Okay. So remember where x and y cross is 0. Okay. 1, 2, 3. Okay. We get given 2 points in this line. We get given coordinate on 1. We get given coordinate 4, 4. Okay. That 1, 1 is going to be our x1, y1. That 4, 4 is going to be our x2, y2. Okay. So we know that m is a change in y. Divided by the change in x. We can put, oops, that's completely wrong. Oh, that's completely wrong. Okay. Which gives a gradient of 1. So that line, gradient of 1. Okay. And that was just 2 random points in that. We could pick another point in that. Okay. And we'd get the same answer. Okay. So we got given that point as well, which is 3, 3. Okay, we could do the same equation, get the same answer. Okay, so we got given 3, 3 on it. How about -1, -1? Okay, so we'll work between these 2 points and we should get the same answer. Okay, so point 1, -1, -1. Okay, point 2 is, what was it, 3 and 3. Gradient equals y2 minus y1. X2. Okay. Did this one a wee bit early, but that becomes a positive. Okay. So you could rewrite that as 3 plus 1, 3 plus 1. Okay, so you'd get the same gradient. So you could pick any 2 points on that entire line. So if that line continued indefinitely, you could pick any 2 coordinates on that line and you would end up with the same gradient. Okay, because the line, if it's a straight line, it doesn't become any steeper at any given point. Okay, at any point along there, along that line, any two coordinates, you'll get the same answer, the same one. Okay, gradient is one. The important thing is here, check here, is it's a positive. So I'm getting a positive gradient. So it looks right to me. Okay, so that's as simple as a gradient question could come. Okay, a gradient of one. Okay, steeper lines than that would be greater than one. Shallower lines, flatter lines would be lower than one. Okay, so it'd be a fraction normal. Okay, so look at another example. Is there any questions at this point? Okay, I sort of rushed this bit. Okay, so remember, just be watching out for your symbols. Okay, so a negative of a negative. So I'm taking away a negative. That becomes a positive. Okay, does that make sense? So just watch out for your symbols. Negative, -1 becomes +1. Okay, so just look out for that. Okay, let's do another example. So I get given a graph with an X and a Y. Okay. I'm given a straight line. Okay. This time it's not going through zero. Okay, and we'll look at that in a wee bit more depth later on. But that happens, it doesn't have to go through zero. Okay, so we get given 2 points in this line. Okay, I'll stretch it out a wee bit. We get given 2 points in this line. Okay, we're given it's not very well drawn, but we get given that, and we get given okay. So it's not a very good two-scale drawing. Okay, but we get given 2 coordinates, 2, 1, 7, 4. Okay, and we get asked the question, calculate the gradient of the line. Okay, so we just write our 2 coordinates out. You can put underneath them x1, y1, x2, y2. Okay, just to keep you right. Okay, I'd recommend doing that. Okay. Write out your equation. That's why I would recommend doing it. Okay. I nearly got that wrong then. Okay. So a positive gradient of 3 divided by 5. That doesn't simplify any further. Okay. But it's a gradient nonetheless. Okay, a positive gradient. Okay. Another example, I won't draw the graph out this time. Okay, there'll be plenty of examples when we go into it. Okay, find the gradient between A Okay, first thing you want to do is just put x1, y1, and x2, y2. Okay. And then it's just a case of working through. Y2, in this case, is negative 16, negative 4. X2 is negative 10, negative 8. Had to shout at someone else. Okay, so you get that equation. Okay, and it's just a case of working through that. So that negative of a negative, okay, you can rewrite that. It's positive 4. Okay, negative 10, negative 8. Okay, so that'd be negative 12 over negative 18. Okay, this is where you need to be careful of the signs, the two negatives there. Okay, so that becomes a positive. A negative divided by a negative becomes a positive. Okay, so essentially we've got 12 over 18. Okay, which simplifies down to 2/3. So that would be our gradient. Okay. So just remember that if both of them are negative, the fraction then becomes a positive. Okay, but if one of them's a negative and one of them's a positive, that stays like that. Okay, so it could be negative 12 over 18. That would simplify down into negative 2/3. Okay, or if it's 12 over negative 18, that would also simplify down to negative 2/3. Okay, but if it's two negatives like this, negative 12 over negative 18, okay, these negatives cancel each other out. Okay, so hopefully that didn't confuse you. Okay, let's do one more. Okay, let's do one more and then have a few examples and then have a wee break. Pardon me. Find the gradient, and you're given A as -1, -4, B as -5, 12. Okay, so first step I would do would just be write x1, y1, x2, y2. Okay, and then your formula, which is change in y over your change in x. So that'd be 12 plus. Okay. So there's only a negative in the bottom, so that negative stays. Okay, so it'll be a negative fraction at the end of it. Okay, that simplifies down to negative, how many times does 4 go into that? -4. Okay, so a negative gradient, so the direction that line would be. Okay. Any questions? So any questions on coordinates? Any questions on gradient as a whole? Okay, seem to be. Okay. Okay, so let's have a wee look. Gradient. Some of the questions. Okay, so question 4, similar to what we've just been doing in 5. Okay. Question 6 is an interesting one. Okay, so when I said we can pick any coordinate on that line, okay, so if that's a straight line, okay, any coordinate on that, if we pick 2 coordinates, we'll get the same gradient. Okay, so what that's asking you to do is prove the following sets are collinear. Collinear means in a straight line. Okay, so if you picked A and B and worked out the gradient, okay, that should give you the same gradient as B and C. Okay, all 3 of them should be points on the same straight line. Okay, so if A and B, the gradient doesn't equal the gradient for B and C, then they're not collinear. Okay, just ignore that. Yeah, just ignore D. Horrible. Don't need to do it. Okay, so we're doing that, just do 6, A, B, and C. Okay, so try a bunch in 4, try a bunch in 5, don't do them all. Try 6, just to see if you can see what I mean. Okay, so do the gradient between A and B, and then do the gradient between B and C. Okay. Ignore 7. Right, ignore, just do 4, 5, and 6. Okay. Ignore 3. Just do 4, 5, and 6. Just work through a bunch of separate ones. Remember the answers. The answers at the back. Okay, that's 7 o'clock. So we've been talking, or 7:05. So we've been talking for an hour. So let's take 30 minutes. Okay, now give me a chance to find an example that we can rearrange. Okay, so let's work for 10 minutes, do as many examples as you can. Not examples, do as many questions as you can. Okay, remember you can find this in Moodle. Okay, work for 10 minutes and then take a wee breather. Okay, we'll come back together at 25 to 8. Okay, we'll come back together at 25 to 8. Okay, guys. Just click on that. Start recording. Normally, we would get given the angle and maybe the radius or the diameter, and would be able to work out either the area of the sector or the perimeter. And that's a pretty straightforward question, quite nice. Okay, but you've seen some of the questions in the exam examples in the booklet. Okay. And also some of the past papers one you might have picked up on that ask you to rearrange for R. Okay, so that's pretty common. So that's why we spent a wee bit of time last week looking at changing the subject in an equation. Okay, so please, if you want to have a look at that, go and have a wee look at that video. Okay, so looking specifically at these questions and changing the subject. Okay, let's do the step-by-steps we discussed last week. Okay, just make sure we're sort of on top of it. So let me share the screen. Okay, so let's have a wee look at this. So I've just made this up, and we'll just work through it. So this isn't an example from the booklet or anything. I just made it up there. Okay, so let's just work through it together. So you're given the area of sector 1. Okay, so sector 1 is the large area. Okay, labelled that up with a very well written 1. Okay, so that'll label 1. So we're looking for the big area there. We're looking for the area of it. Okay, so area of sector 1, we've given 1,000 centimetres squared. Okay, so remember, areas will be something squared. So millimetres squared, centimetres squared, metres squared. Okay, so look out for that. Okay, the angle we've been given is a reflex angle, it's 315 degrees. Okay, so if you look at that angle, it makes sense that it's a large area. Okay, so remember the full circle is 360 degrees. Okay, so that means the small area is just going to be, what's that, 45 degrees. Okay, that small area would be. Okay, so they've given us the area, they've given us the angle, we've asked to find R. So let's just write out that equation and then just do the steps from it. Okay, so area sector. Okay, so area of sector equals the angle over 360. Okay, that's just a ratio multiplied by pi r squared. Okay, so remember, that's just the equation for the area of a circle. Okay, and that's just effectively working out the ratio of how much of that area that sector's got. Okay, so nothing too tricky. You're not given it, so you need to know it. Okay, so area sector, let's just plug in our numbers. So 1,000 equals 315 over 360 multiplied by pi multiplied by r squared. Okay, so we've got to this point. Okay, so there's a couple of different ways to approach this. Okay, one way is to do step by step. So you put that in your calculator, you find that out. Okay, then you multiply that by pi, and that gives you something on the right-hand side times r squared. Okay, that means you can just move one number over. Okay, other, I'd say maybe more complicated way would be move 360 first, then the 315 would go over here, and then pi would come over as well. Okay, perfectly reasonable way to do it if you're comfortable with it. It's a wee bit harder to put in your calculator at that stage. Okay, you need to get that equation right when you put it in your calculator, or it will throw out a number that was a wee bit disturbing. Okay, so I would probably recommend do as much as the calculation as possible when it's in the same side, and then when you've got that sort of answer, move that across. Okay, I'll do both here just so we've got that. Okay, so if we were just doing that, if we were leaving that 1,000 as is, let's do 315. 315 divided by 360. Okay, it's 0.875 multiplied by pi. Okay, it would give us 2.75 if I round it to do 2 decimal points, r squared. Okay, so that's a wee bit more digestible, it's a wee bit more easier to work with. Okay, so it makes sense doing that. So that I'd probably recommend, as far as possible, work out when it's still on one side and then move that all across. Okay, so now we need to organize that to find R. Okay, so I've told you to write down BODMAS or BIDMAS. Okay, the BODMAS is the order in which we carry out calculations. Okay, so if we had a calculation we were carrying out, we'd do the brackets first, then we'd do the order. Okay, so any indices. Okay, we'd do divide and multiply, so it comes together. Okay, and so does add and subtract. Okay, so you can do them in any order, but it makes sense just to follow that through. Okay. For rearranging the subject to find another part of the equation, we do that in reverse. Okay, and what I mean by that, we look for any add and subtract first, and we move them across. Then we look for any multiply and divide, and then we move that across. We look for any order, i.e. indices. Okay, we move that across, and then we break the brackets out and we can tidy that up. Okay, so we do it in reverse. So reverse BODMAS. Start at this side and work that way. Okay, so let's have a wee look and let's try and figure out how we get to this r squared. Okay, so there's no add and subtract in this calculation. Okay, so we don't have that, we don't have that. Okay, so we're working from right to left. Next one we come across is this multiply. Okay, so that 2.75 times r squared, that's a multiplication. Okay, so that's the step that we want to take across first. We want to remove this 2.75 and take it over there. Okay, and we're going to do that by the rule of change side, change sign. Okay, that is just follow that. Change side, change sign. Okay, so remember that equation there, that 1000 equals 2.75 r squared. That's like a seesaw, it's balanced. Okay, so the left-hand side is currently equal to the right-hand side. So if we do anything to the right-hand side, so if we're removing that 2.75, we effectively need to do the same to the other side to keep that balance. Okay, so if you think about it like that, some people like that way of thinking about it and knowing about it. Okay, so whatever you do to the right-hand side, you need to do to the left and vice versa. Okay, so we're moving that 2.75 just to leave that r squared on its own. Okay, so on the left-hand side, it becomes 1000 divided by 2.75. On the right-hand side, we've now just got r squared. Okay, so again, just tidy that up. Okay, so 1000 divided by 2.75. See, 363.6 equals r squared. Okay, so just keep things tidy. If you can do a bit of the calculation, okay, do it in your calculator, simplify it. Okay, make your life easier. It's a wee bit neater now. Okay, the only thing now we're left with is this squared. Okay, so we want to move that squared to the other side. Okay, so there's no additions left, there's no multiplications, nothing to divide, there's no, oh sorry, there is an order. Okay, so that's what the O is in BODMAS. Okay, some resources, some places you'll see it written as BIDMAS, means the exact same thing. Okay, that just means index or indus or whatever. Okay, in that one it means order, but it means the same thing. Okay, so don't be put off by that if you see an arrow. So there was none of that. There was a multiplication. We've moved that. There was no divide. There was a indus. So we want to move that across. Okay, so that was number one. That's our second order. Okay, so moving that across, change side, change sign. What's the opposite of doing a squared? It's doing a root. So that square becomes a root. Okay. So it becomes root 363.6 equals r. Okay, so 363.6. Oh, the root 363.6. So 19.1. And remember to put the units. Okay, equals r. Now, just to be a wee bit neater, r equals 19.1 centimeters. Just flip it. Okay, same thing. It's just a seesaw. Okay, so if you turn the seesaw around, it's still balanced. Okay, that's all I've done there. So 19.1 centimeters. Remember the units, really, really important that these units are correct. Okay, you get a mark for that. It's such an easy mark. Don't forget it. Okay, so that will leave you with r, that will leave you with the radius. Okay, remember if it asks for diameter, just double that. Okay, but it's that reverse bid mass, that reverse bod mass that you sort of just focus on. Okay, now I said, let's do it so we tidy it at each stage. Okay, you don't necessarily have to do that. So when you're looking at the order of it, okay, so if we go back to this stage, I'll take that across. Okay. Wait, bid mass over here. Okay, so again, there's no add and subtract. We're working right to left, so we're working in this direction. There's no add and subtract. There is a couple of dividers and a multiplication. So, okay, so each one of them has to come over at different points. All right. So we've got this multiplied by pi, so we want that to come across. Okay, so we'd have 1,000 divided by pi equals 315. Okay, then we've got this dividing needs to come across. That divide becomes a multiply. Okay, then that needs to come across. That's a multiply on the right hand side, so it becomes a divide on the other side. Okay, now this is where it's important you put this in your calculator the right way. Okay, some calculators will skew it up. You need to put that bottom bit in a bracket, okay, and that top bit in a bracket. Okay, or you just need to do it in the right order. Okay, so that's why it's a wee bit more difficult to do. Okay, you could also move the square over at this time, make it a really nasty one to put in your calculator. Okay, there's nothing wrong with you writing it like that. Everything's mathematical. Everything's mathematically correct. It's just a pain to put in your calculator and not make a mistake. All right, so go through it step by step and just be quite tidy with it. Okay, I'm going to try and put that in, see what happens. Put that into the right sum. Yeah, so it comes out the same. It's just it takes a wee bit of care to put it in. All right, that is mathematically correct. Do it either way. Okay, just write out the steps that you've taken. Okay, because remember, if you make a mistake part of the way through, as long as you follow the process correctly, but carry through that mistake, you'll still get marks. All right, so if you made a mistake at this stage, but give the correct working for the rest, you'll get like 2 out of 3 marks. All right, so just write everything down step by step. Don't just get this and then put it in the calculator and just put R equals. All right, sometimes quite tempting in the calculator paper. Just smash everything into the calculator and just just make sure you do step by step by step. Make sure the marker knows what you've done and you're thinking. Okay, you might pick up a couple of marks here and there, even if your answer's way off. All right. So hopefully that answers your question, Sandra. So it's this reverse BODMAS, this reverse BIDMAS is really the important bit. Super. Right, let's get back to straight lines. We'll look at it. We'll look at an equation. Okay, so that's actually quite nice. It fits quite well. Okay, so thinking about what an equation is. Okay, let's do that. Okay. Back to straight lines. So we've looked at the gradient. So the gradient's all about how steep it is. So it's all about how far up it goes or down. And it's all about the relationship between that and how far along it goes. Okay, so the vertical, change in vertical divided by the change in horizontal. Okay, so quite nice. Okay, where does that fit in with our further understanding of it? And what other bits of information do we need to do some sort of analysis? Okay, so how do we use that gradient in something? All right. It allows us to understand linear relationships. By linear, I mean straight lines. Okay, linear relationship just means it's rising at a straight line. Okay, so what are the important features? That we need to be aware of for straight lines. Okay, so obviously gradient's one. Okay, and that's what we've been looking at. Okay. Another one is where crosses the x-axis. Okay, so that's an important thing that we need to consider, where it crosses the x-axis. Okay, so I'll draw a graph out in a minute. Okay, if we consider where that line, that straight line, it's going down, it's going down, it's going down, it's going to finally cut through that x-axis and then start going into its negatives, or start in the negatives, then go through the x-axis and start being positive. Okay, so understanding where it goes from negative to positive is quite important. Okay, now that's going to happen, an important point, and it's going to happen when y equals 0. Okay, so it's going to happen when the vertical is at y equals 0. Okay, so that's an important point. Okay, so let me just draw a graph so we can think about what I'm meaning. Okay, we've got the y-axis there. We've got the x-axis like that. Okay. So where it crosses the x-axis, so if we've got, let's do a straight line instead of me just sketching. We've got a line like that. Okay. The point at which that crosses the x-axis, okay, y is going to equal 0. Okay, so on the vertical, okay, it's going to go up, it's going to go 1, 2, 3, 4. Okay, that's going to continue going up. Okay, that scale. It's going to continue going down as well. Okay. Where that crosses the x-axis, it's called the graph's root. Okay. Now, what we've been doing when we've been doing factorization is finding the roots of an equation. Okay. That skill we've been learning is essentially finding that point. It's where the graph crosses the x-axis. Okay. So we're effectively setting that equation, that function, to 0. Okay, so when y equals 0. Okay, don't worry if that doesn't make too much sense. When we go through examples, it will start coming out. Okay, so important features: gradient, how steep the line is, where it crosses the x-axis. Okay, and we call that the root, or the roots if there's 2. Okay. Other important feature, something called the y-intercept. Okay, or where it crosses the y-axis. Okay, now that's an important feature because that happens when x equals 0. Okay, so let's look at the graph again. Okay, where does that intercept the y? It intercepts the y at that point there. Okay, at that point, we've not traveled horizontally left or right. We're at 0 on the x-axis. Okay, so it cuts the y, it intercepts the y-axis at 0 when x equals 0. Okay, let's write that out and draw that on a graph. Okay. So if I wrote the equation y equals x, okay, so that's a linear equation. Okay, that's effectively an equation that will give me a straight line. Okay, so let's think about what that means on the graph. We've got a scale. 1, 2, 3, 4. Okay. This is easier with squared paper. I forgot to say. Okay, so that's the x-axis. Okay, what that equation tells me, when y is equal to 0, x is also equal to 0. Okay, when y is equal to 1, x is equal to 1. Okay, when y is equal to 2, x is equal to 2, y is equal to 3, x is equal to 3, y is equal to 4. Okay, so you can see if you plot all those points out, okay, you're going to get a straight line. Okay. All those x's should be on that line. Okay, so y equals x is a straight line that goes through the origin, which is 0. Okay, it intercepts y at 0. Okay, when x is equal to 0. Okay, and it intercepts x at 0 when y is equal to 0. Okay. Write that out. So 2 equals 2. 3 equals 3. Minus 3 equals minus 3. Okay, you can do that for any coordinate. So when you've got x equals 2, you know y equals 2. When you've got x equals 4, you know y equals 4. Okay. Now, obviously, we're working with harder equations than that. Let's keep it without moving it from cutting through the origin. Okay. Should I draw these out? So we got y is equal to 3x. Okay. That means when y equals 0, x is still equal to 0. Okay. So let's just draw that out. Okay. So when y equals 0, x equals 0. When y equals 1, x, okay, sorry, when y equals, sorry, when x equals 3, what am I trying to say here? When x equals 1, y equals 3. All right. Let's draw that out a wee bit better. 1, 2, 3, 4. Let me extend that line. Let me just work on that 2 seconds. Okay. So when x equals 1, oh, some chestnut. X equals 1, y equals 3. Okay. So we go back into this. If x is equal to 1 on the x-axis, okay, effectively that's just y equals 3 times 1. Okay, so y equals 3. Okay, so we're on the x-axis and we're at 1, means y equals 3. Okay, if x was 2, y would equal 3 times 2, so y would equal 6. Okay, if x is negative, x is negative 1, okay, y would be negative 3. Okay, so again, we're just substituting that in. So x equals negative 1, y equals 3 multiplied by negative 1, so y equals negative 3. Okay, so your coordinate for that point, we were putting the coordinate in, it would be 1, 3. Okay, so we're substituting in the x value, okay, and multiplying it with whatever numbers in front of it. Okay, now this gives us a very important relationship. Okay, so that line should go through all the x's. Okay. That 3 then, okay, if we look at it, that 3 is actually giving us the gradient. Okay, so if we look at that equation, y equals 3x, that number in front of the x is actually the gradient. Okay. So if we were to take a couple of those points and did our gradient equation, get the gradient of 3. So that number in front of the x is very, very important. Okay, so the number in front of the x is the gradient. Okay, so m. Okay, so that gives us a sort of first part of the equation. So we can say that y equals mx. Okay, so we can say y equals mx. Now there was another important part of it. Okay, and that's where it crosses the y-axis. Okay, so we've got where it crosses the x-axis. It crosses the x-axis when y equals 0. Okay, part of the equation, we need to know where it crosses the y-axis. And that's going to be this. Okay, so we're going to plus c. So we've got an equation that's got the gradient. Then we've got an equation that gives the y-intercept. Now the examples that we've just done, okay, y equals x and y equals 3x, okay, they crossed the y-axis at 0. Therefore, there's no plus anything. Okay, if we were to move that line up 1, okay, or down 1, okay, that plus c would become relevant. Okay, so if we move that line up 1, okay, and it cut through the y-axis at plus 1, the equation would be 3x plus 1. Okay, that tells me that for whatever x I am, at whatever point I am in the x-axis, multiply that by 3, and then we plus 1 onto it because that line's moved up a wee bit. Okay, so when x is equal to 1, okay, y would be equal to 3 times 1 plus 1. So y would be equal to 3 plus 1. Okay, so the coordinate 1, 4. You can see it's just shifted 1 up. Okay, so that plus c part of that equation, okay, is important because it's where it cuts the y-intercept. Okay, so let's make that disappear a wee bit. If you got given a question and you were given the equation of a straight line, okay, you would be able to take away from that gradient equals 6. Okay, the y-intercept equals 9. Okay. If we were to draw that and put a point on it, okay, for the y-axis, x and y cross at 0. Okay, we said that's 9. Okay. 6x is quite steep. So cross like that. Okay. That point there, the coordinate is 0, 9. So the x equals 0 and the y equals 9. Okay, so the y-intercept, the x coordinate is always 0. Now, if we moved a long one and x was 1, okay, at that point, at x equals 1, y would equal 6 times 1 plus 9. Okay, so y would equal 15. Okay, so that coordinate, if we went up, along, okay, at x equals 1, y equals 15. Okay. At x equals minus 1. Okay. Y would equal 6 multiplied by minus 1 plus 9. I'm way off. Jesus. Okay, it's not a very good scale. But when y is equal to minus 1, sorry, when x is equal to minus 1, y is equal to 3. Okay, so minus 1 was here. Okay, so it's a poor scale, but that's essentially what we're doing. Okay, so there's quite a lot going on there. Okay, what I'm looking for you to understand is that's the gradient, what we've been using as m. That's your y-intercept. And that's wherever we are on the x-axis. And that would be the corresponding position on the y-axis. Okay, so that's your x coordinate, and that's your y coordinate. Okay, so when the x coordinate equals 1, the y coordinate would be 15. When the x coordinate is minus 1, the y coordinate is 3. Okay, when the y coordinate is 0, okay, oh no, sorry, when the x coordinate is 0, y would equal 9. Okay, because it would be 6 times 0. Okay, which would rule that out, which would just leave you with a plus 9. Okay, so when the x coordinate is 0, you're left with the y-intercept, which should just be plus 9. Okay. Let me try something. try to change the background to squared paper because I think it'd be a lot easier to see. I can. Do it to your Santa list. Okay, frustratingly, I don't have squared paper. Oh, I don't even know what I do. Okay, right. Let's have a wee look at what that looks like question-wise. Okay, so interestingly, this is actually in the new booklet. It's in the relationships booklet. Okay, so the equation of a straight line is in the relationships booklet, so it's in booklet 2. The gradient stuff is in booklet 1. Bizarrely, but they flow into each other. So we're taking the knowledge that we've learned about gradient and we're applying it more to the relationships now. Okay. So some of the questions. So for each line, write down the gradient and the coordinates of the point that crosses the y-axis. Zoom that in. Okay, y equals 3x plus 1. Is that the one I just did? Okay. Gradient is 3. Y-axis is going to intersect at 1. Okay. For B, gradient is a half. It would intercept the y-axis at -5. Okay, there's a negative gradient and a negative y-axis. Okay. Really, I need square paper or a square diagram to allow you to see that, which is frustrating. Let's have a wee look at this. I'm looking to see if they've got a very good graph that we can look at. All right, so what essentially question 2 is looking for you to understand is, remember the direction of the lines, tell you if it's negative or positive. All right, so A, B, E, and F are all positive gradients. All right, and C and D are negative gradients because of the direction of the line. Okay, so if you imagine standing in that slope, you'd be going uphill on A, B, E, and F, downhill on C and D. Okay, so positive gradients, you're going to apply to the ones that are going in a positive way. Negative gradients, you'd apply to the negative ones. Okay, then you've got the y-intercept. So number 1 is a positive gradient and it's a positive intercept. Okay, so you could attach that to B. Okay, so 1 y equals x plus 1, you could attach to B. Okay. 6x minus 2, it's a positive gradient, but it's a negative y-intercept. So it's going in a positive direction, but it cuts the y-intercept in a negative position. All right, so it cuts this y-axis in a negative position. So that 5, you could put onto A. Okay. One of the negative ones, so if you go -2, -3, okay, so the gradient's -2, so it's going to go in a negative direction, okay, downward slope. Okay, so that can be applied to C or D, but the y-intercept is going to be -3, so it rules out graph C, because that's got a positive y-intercept. whereas graph D's got a negative out. So it's a negative gradient and it's a negative y-intercept. Okay. That's quite tough to do without squared paper. Right. Don't know how well you can see these. Let's have a wee look at them. Okay, so we might be able to use this. Right. Question A. Write down the equation of the lines drawn. Okay, so you get given a line. You've got an x-axis and a y-axis. Okay. So the 3 points of what I'm interested in. The gradient, where it crosses the x-axis, where it crosses the y-axis. Okay, so that's the 3 key points. For the equation of the straight line, y equals mx plus c, we need the gradient. Okay, so to find out the gradient, we need at least 2 points in that straight line. And the y-intercept, okay, effectively we just need to look at it and see where it cuts the y-axis. So if we take one box as 1 unit, okay, let's pick a couple of points on this graph to find the gradient. Okay, and then if we take one box as 1 unit, where does it cut the y-axis? Okay, and use that. So I want 2 coordinates off of this, and it could be any 2 points. Remember, as long as you've got 2 points in that straight line, you can work out the gradient. Okay, so I'm going to take a positive one. Okay, so it's gone along x1, and it's gone up y, 1, 2, 3, 4. Okay, so that point there, okay, it's gone along x1. A bit thicker. What does that look like? No. So you put a bracket, the coordinate's going to be 3, and it's going up 4. So that's going to be coordinate 3, 4. Okay, so we want another coordinate. How about this point here? Okay, so we've gone along the x-axis -2. And we've gone along the y-axis, again, -2. Okay, so we've got 2 coordinates. Okay, 3, 4, and -2, -2. Okay. So stop annotating. Oh. Okay, so we've got 2 coordinates. Let's take that in here. Okay, so coordinate 1, coordinate 2. Okay. So it's going to give us a positive. So let's make that x1, x2. Oh, sorry, my God, sorry. x1, y1. x2, y2. Okay. Gradient, change in y, change in x. -2 would have been -4. -2 again, and we're going to be -3. Okay, so that's going to give us -6 over -5. Weird gradient. Okay, the two minuses cancel each other out. We've got a gradient of 6/5. Okay, which is bizarre. Okay, so we've got the m part, so we've got the gradient part of that equation. Okay, now we need where it cuts the y-intercept. Okay. So when x is equal to 0, it's cutting the y-intercept at +2. Okay, you see that? So when x is equal to 0, it's cutting at +2. Okay, so it's cutting through that y-axis at +2. Okay. So if we go back, y-intercept. Okay. So we can put pi equals mx. The equation of this straight line would be y equals mx plus c. Y equals 6/5x plus 2. Okay. A weird gradient. 4, 6/5. That's why the gradient's weird. Why did I put 3? My God. Why did I write 3? That point there is 1, 4. I have no idea why I wrote 3. That's why the gradient's weird. Oh, let's blame tiredness. I have no idea where I got 3. I don't know how I got it. You've gone along x once, one box, and you go up 4. So the coordinate's 1, 4. I can only apologize. Let's try that again. Okay, that's 1, 4. That coordinate is -2, 1, 2, 1, 2, -2, -2. And that changes the sum completely. It did look weird, don't, right. My God. So the first point is 1, 4. Just throw that out, whatever I just did to you. Okay, so that's our 2 points. Can I blame Christmas? Too early. Right, let's try that again. Y2 minus y1, x2 minus x1 to find the gradient, -2 minus 4 over -2 minus 1. Okay, so -6 over -3. Negatives cancel each other out. That becomes gradient 2, which is a much nicer gradient and makes a lot more sense. Okay, the y-intercept is definitely when x is equal to 0, it cuts through at +2. Okay, so the y-intercept is 0, 2. Okay, And the equation of the straight line equals y 2x plus 2, which looks much nicer. So throw out that first one I did, where I somehow got a coordinate of 3, 4, picked out of nowhere. Okay, so that coordinate, the first coordinate we picked off that line, 1 box along, 4 boxes up. Second coordinate, 2 boxes in, 2 boxes down, both in the negative direction. We could pick any coordinate. As long as we pick it correctly, we can pick any coordinate. Even where it crosses the y-axis, we can use that as one of the coordinates. It's not a problem. Okay. This one down here, we could use, what's that, -3, -4. Okay, we could use that coordinate and that coordinate, whatever. Okay, as long as there's 2 points that are on that line, and as long as the coordinate's correct, okay, you'll get the right gradient. Have a wee go while we're together. Have a wee go at B for me. Okay, so pick 2 points in that line, okay, to find the gradient, and then look at where it cuts the y-intercept, and then put it into the equation of a straight line. Okay. So take 3 minutes. Try and do that in 3 minutes. Okay, so you should have a positive gradient of 1/2, and you should have a y-intercept of -1 if I've done it correctly. All right, so I've picked points 4, 1 and -4, 3. Okay, so when x is equal to 4, y is equal to 1. When x is equal to -4, y is equal to -3. Okay. Anyone not get that? close to that. All right. I say at this point, because I can't count a simple box, that we call it a night.
You're going to leave the video up as well for us.
Yeah, I'll put the video up. It's not a problem. So it takes a wee bit of time to download, so probably tomorrow morning, but I'll fire you across an email when I've done that, all right? And I'll put in that email that link to the site that we spoke about today. All right, so have a wee look at that, see if there's any past paper questions, okay? It seems they seem to have broken it down quite nicely. All right, so look for obviously the titles that we've done. All right, I don't think they've ordered it the same way that we do it, but just look out for that. All right. Okay, have a look at a couple of those questions. Have a look at a couple of the resources. Okay, try and digest that a wee bit. Okay, so takeaways, the three important things: gradient, where it cuts the y-intercept, and where it cuts the x-intercept. I've not spoken a lot about the x-intercept part. Okay, that becomes more important later on. But the y-intercept and the gradient for the equation of a straight line. Okay, so an equation in this format is the equation of a straight line. Okay. Super, guys. Okay, let's call it a night. Let's call it a night. Okay, so next Tuesday, 6 o'clock. 6 o'clock? Yeah, 6 o'clock. Next Tuesday, 6 o'clock. And we'll go through some more stuff. All right. And then we'll go off on a Christmas break. Okay. Let's call it a night there, guys. Any questions, fire it to me through the week.
Thank you.
Nice one, Aaron. Nice one, Sandra. See ya.
Have a nice weekend.